Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Packaging Digest webinar, Packaging MythBusters, Right-Sizing Your Medical Device Packaging, sponsored by Oliver Healthcare Packaging and broadcast by Informa. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in our Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event, and you may also download a copy of the slides via the resources widget. Towards the end of our webinar, we will ask you to complete our survey found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And lastly, if you're experiencing any technical problems, please click on the Help widget found at the bottom of your screen or type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now on to the presentation. Packaging MythBusters, Right-Sizing Your Medical Device Packaging. Discussing today's topic are Jeremy Elwell, Senior Principal Engineer at Oliver Healthcare Packaging, and Kevin Fisher, Technical Manager at Oliver Healthcare Packaging. To learn more about our speakers, please visit the Bios widget. It's with great pleasure I now turn this special session over to Jeremy to begin. Jeremy, take it away.
Thank you, Chris. Hello, everyone, and thank you for joining our webinar today. I'm Jeremy Elwell, and with me I have Kevin Fisher.
Hello.
So in this webinar, we'll be talking about right-sizing your sterile barrier packaging. What right-sizing means to us is to consider the size, shape, and material characteristics of your packaging. We'll provide some tips and tricks for packaging design. We'll also talk about some myths and misconceptions in the industry today. And then we'll go through a case study to wrap things up. But first we'll talk about common defects when using an undersized pouch system. The first slide is a video. And this video shows the stress that a packaging system could undergo during a vibration cycle in simulated distribution. You can see that the pouch is not very correctly sized. There's a lot of wrinkling going on, and the materials are being flexed and stressed. So it's being thrown around in a chaotic way, and this is very common during this testing cycle. So stress that occurs during manufacturing, transportation, and handling can cause defects in the sterile packaging system if not properly sized. The following slide shows some potential risks to the sterile barrier packaging. So first we'll talk about some of the defects that could happen. So throughout this webinar, we'll be talking about a Tyvek pouch configuration that is undersized. Some of the common defects, this isn't all of them, but these are very common defects that could happen when we're undersized. The defects can all look similar in these situations, so it's important to understand the root cause. So the first defect we'll talk about is seal creep. So when a bulky device is tightly packed in a pouch like this, the bulky device can start to stress the materials, pulling the Tyvek and the film apart and causing a little bit of creep in the seal area. So as you can see in the picture right there is that the dye penetration testing is a good way to detect this. So this can happen during manufacturing and normal handling, but it is more likely to happen in high temperature, high vacuum situations like EO sterilization. This can also happen during high altitude shipments like air shipments or even ground shipments that maybe go over mountains. The next defect is wrinkling in the sealing area. Now these wrinkles can occur for many reasons, but in this situation, the bulky device is causing the pouch materials to not lay flat in the seal area and cause these channels that occur. So when you're thinking about packaging design and right-sizing your pouch, you want to consider the process as well, very early in the process, and make sure that you consider all aspects of the process. So the next defect that could occur is puncture. And this is a very common defect. I know a lot of people are probably familiar with this. So this can be caused for many reasons as well. In this situation, what we're looking at, there's an area of the device that may have some flash on it from the injection molding process or other sharp edges that could puncture through the material. And when it's undersized, when the pouch material is undersized, there's a lot of force on that tight material area, so it could be more than usual. This can even be emphasized during the shipping and handling process and in simulated distribution like the video we saw earlier. We'll talk a little bit more about puncture resistance in a later slide. The next defect on the list is flex cracking. Now, flex cracking is often overlooked and not very well known in our industry from a common defect sort of perspective. So flex cracking can occur when the film side of the pouch is wrinkled and repeatedly flexed, mostly during the vibration cycle of distribution, like the video we saw earlier. When repeated flexing happens, you'll see these little stress marks that turn a little bit white, and that eventually could turn into a pinhole. So you can detect this type of defect by looking for those stressed areas and looking for a possible hole, maybe under magnification. We'll also talk a little bit more about flex cracking in a later slide. The next defect is abrasion. So abrasion can occur when you have an area of your film that is wrinkled and actually comes to a point. And then that point rubs up against a shipping container or a shelf carton during vibration. You could get these scratches and start to cause a defect in the surface of your film. It could eventually wear through and cause a pinhole in your system. So the last three defects we talked about right there in the middle really are all pinholes. So again, it's important to think about what the root cause may be, because a pinhole could look similar in other situations, but when you're trying to detect the root cause, you want to try to look at these under magnification and look closer to see the area around the pinhole and in other areas of evidence so you can find out what's causing it. Tyvek can also be a pinhole due to abrasion. And Tyvek tenting is a very common defect that happens, and sometimes it can't be completely avoided. But to watch out for that, it's the same type of defect that may occur with the film side, where the Tyvek comes to a point and rubs up against the carton or shipper until possibly a hole appears. So also, just like flex cracking, repeated flexing during vibration of the Tyvek area could cause sheet separation. Sheet separation could cause issues with your sterile barrier system, but also could cause a false positive in dye penetration testing. So we would like to avoid Tyvek tenting, and we also recommend avoiding any severe creasing or intended folding of your package, since this can also cause that sheet separation. There's a lot of white papers out there online to go more into this issue, so we will move on for now. Last but not least, another defect, a common defect that could occur is on your device itself. So device damage could occur maybe if the packaging is too large and there's unintended movement within the package, but also could happen if the package is too small. So in this situation here, there's a catheter. And this is a very fragile device. It's very loose. It's prone to kinking. So if it's a tight fit in this pouch, any external forces on the pouch could force this kinking to occur. So we've discussed some common defects that could happen. Now we're going to discuss some of the solutions that should be thought about early in the development process that would give you a high probability of passing your verification validation early. So the first solution might be an obvious one, is to change the pouch size. Also we have in here is to add or change the pouch style. So it's very common out there, and in my experience, medical device manufacturers like to use existing packaging, and a lot of the times that's okay. It does save time and cost in most situations. But if it's not right size and you're forcing a device to fit in a pouch, then it could actually cause you more time and cost later on in the project due to rework or issues in testing. So as a responsible party for packaging design, it's important to understand these defects and why right sizing is important. Also, you can consider these different style pouches we have here on the right side of the slide. So the chevron pouch is one of the most common types of pouches in our industry. But we also have corner peel and square cut type of pouches. So depending on the size and shape of your device, you may want to consider a different style. So with our example that we've had here that we've been talking about with the defects, changing the pouch size actually could help with most of the defects that we've seen. The puncture may not be as likely because the stress of the tight film, it's not so tight anymore and it may not have as much risk of puncture. The abrasion, due to wrinkling, abrasion, and flex cracking, those may not be as possible because you're not wrinkling as much with a more relaxed film. Also, if you have the right size pouch, if it's a little bit wider, you're not going to have as much pressure. The device won't be as close to the seal, so you won't have pressure on the seal and you may not see as much seal creep. And lastly, right sizing your pouch could reduce the amount of protective packaging needed because your packaging materials are looser, there's not as much stress on them, and you may not need to protect it with your carton, your shipper, or any other protective packaging. So that could be a cost avoidance as well. The second solution is to consider your adhesive. So with a Tyvek pouch, you may or may not be using an adhesive on your Tyvek, but just know that different adhesives are available that have different types of functionality. So there's advantages to using these adhesives, and the first one is adhesive strength, also cohesive peel, and adhesive transfer. You can use adhesive strength to your advantage if you have heavier, bulky items, and you can also lower the adhesive strength for if you want a more easy to open package. So the adhesives are out there that have different levels of adhesive strength. All adhesives are designed for cohesive peel, and what cohesive peel is, if you look at the diagram on this slide, the green area is the Tyvek, the gray area is the adhesive on the Tyvek, and then the blue area is the film. So while the Tyvek is being pulled away from the film during the opening process, the adhesive is being cohesively split, and there's remaining adhesive on the Tyvek and the film. This allows for a softer peel open, and again, you can control some of the characteristics of your peel. The area of adhesive that's remaining, the gray area on the bottom that's still remaining on the film side, which is the blue portion, that is the adhesive transfer. So adhesive transfer gives you the evidence that you had a good seal and that the sterile barrier was still intact and the end user can inspect it easily. Adhesives are, you can choose adhesives out there for different higher level adhesive transfer and to adjust all of these different aspects. So the third solution, and again, these can all be combined into one solution as well. So the third solution is material selection. And this aspect is very critical and sometimes overlooked. I've seen a lot of situations where something that exists is being used for a lot of different devices, but it may not always be the best solution. You may want to have a stronger film for more protection, but you may also in some situations want a thinner gauge material for a lower cost when you don't need as much protection. So there are many films and laminations available for different applications. In this situation with this bulky device, we are worried a little bit about the higher risk of puncture. So in this situation, we're going to look at a nylon-based pouch. So in this graph below, you can see from the x-axis is the pounds force to puncture through the material, and the x-axis is the material type. So from left to right, we start with polyester. Then when you double the thickness of polyester, you get about twice the puncture resistance. And then moving to 100 gauge bond, you get more resistance in different bond, meaning biaxially oriented nylon. Different types of nylon will give you different puncture resistance. So the one on the far right is one of the highest and we would use that in this, maybe in this particular setting. Keep in mind, though, back to that slide, that nylon, the use of nylon can be increased in cost. So keep that in mind. The more puncture resistant, the more protection you're getting, you want to be cost conscious if that's what your project is asking for. So the fourth solution is to transfer to another packaging type. So sometimes this is the best option. In our example, we have a two-dimensional pouch with a bulky item in it. We could make that work, and we could adjust the size and everything that we talked about to do it. Sometimes the best option is to go to a three-dimensional pouch. So when you're making this decision, some considerations are to think about cost, user experience, and capital investment. So some options for three-dimensional packaging configurations are rigid trays and FFS pouch, which is form, fill, seal. A rigid tray can really improve your user experience. It's one of the best. It can also lower risk, but it could affect your material cost. FFS pouches could lower risk and material cost, but it could be a high capital investment. So it's important in these situations to consider your project team, your company, and what kind of aspects you want to invest in or adjust for your device. Kevin, can you walk us through the fifth option here?
Absolutely. I think the fifth solution is a high-density polyethylene card, or an HDPE. If you refer back to Jeremy's slide, he showed a tight pouch and a high-profile round device. We see that a lot, and it has unwanted creases. This might seem a little counterintuitive, but adding a card could help reduce or even eliminate those unwanted creases and shapes when the pouch is misfitted like that. I understand the need to use a pouch that's in the closet or it's previous validated. It makes it faster and easier, and that might be a nice little solution for that. But to go into the benefits of HDP cards, the cards allow you to properly size the pouch around the device, but it limits unwanted movement and creases that would occur without the card itself. The card aids in device retention. I think we all agree that a retained device has many positives. And then not only do cards protect the device, but the card also protects the sterile barrier from the device itself. I think that's key. It only takes one pinhole to ruin a packaging engineer's day. And the last benefit is it's very low profile. The best part of cards is it doesn't add height to the packaging typically. If you add height to a package, you need to increase the width of the pouch, which then increases the shelf in the shipper to fit properly, and a larger footprint on a package is never a good thing.
Thanks, Kevin. So now that we reviewed some of the defects and solutions that could avoid those defects, we're going to talk a little bit about myths and misconceptions about some of these solutions that we've run across in our experience. So Kevin, you've talked about the HDPE cards and how they can help right-size a package, but are they dirtier than other types of packaging solutions?
Well, the simple answer is no, but I'll go into a little bit more. I think cards in general have earned that reputation a little bit over the years. These types of cards have been made for 20 plus years, and much of the time from paper material, which is particulate driven, and intended as more of a bridge, Jeremy, to get to A to B and not necessarily to A to Z. It was traditionally used for quickly upcoming events such as animal studies. So you got to think about that. Not necessarily for the product to be FDA approved and then launched. I think today, due to more innovative and thoughtful designs, this bridge thought process is not necessarily the case anymore. Now, you got to remember that not all cards are created equal. You have medical device packaging companies that know what's expected, and then you have companies that make packaging cards possibly intended for medical. The two things are important when looking for a card provider, in my opinion. You want to make sure, one, it's their core product. You want it to be their top 1 to 3 products that they make and not number 20 or 21 down the list. Number 20 and 21, to me, could mean that they're cutting cards in the back of the warehouse with the bay doors open next to the riverbed. And then you have core product, which will get money reinvested in the process. And I think that's key. You got to have revenue generating toward that product so you can add to it. And then you want to make sure a majority of the business is medical device, or at least a significant amount. That way they know what the MDM or the contract manufacturer is expecting at the end of the day, in my opinion. Also, die-cut companies that make cards for medical device can't afford to install the needed processes and quality checks demanded by our industry. And medical device packaging companies, they can't afford not to implement this. If they don't, they'll quickly get cut from the team, in my opinion. If we go to the slide here, I'm just going to talk a little bit about what we do to implement some of this, or what we do to make sure you have the best packaging going out the door, the cleanest possible packaging from the industry. We cut all our cards or convert them in an ISO 8 clean room, and then it's taken to an ISO 7. It's cleaned, double bagged, green labeled, and then shipped out to the customer. We also don't use a regrind. It's virgin HDPE tubing and cardstock. That's what we start with. And all raw materials are heavily inspected for cleanliness when coming in. If you don't start with good material, it's almost impossible to send a good product out the door. And the last thing is we have our quality department that can issue the MSDS, the technical data sheets, the biocomp, the cytotoxicity testing. All that paperwork's there to share with our customers as needed.
Great, Kevin. I think we've busted that myth. How about particulate? You talked a lot about the cleanliness, but I've heard that maybe cards cause a little bit particulate during the process. Is that true?
I don't think cards cause the particulate. I think the die cutting process could create particulate if certain steps and measures are not put into place. Bad card designs often contribute to this, or starting with inferior material, as I mentioned. All this could cause imperfections, in my opinion, which are quality group labels as angel hairs or flash or stringers. Potential sharp edges are never good as well. All card companies should provide the QS or quality standards to their client. When a customer receives and reviews their order, they should know exactly what to approve and reject for. Nothing should be in the gray area. Everything should be quantifiable and not subjective. But there's one thing that has zero tolerance, in my opinion. That is a loose particulate. A customer should be able to comfortably and add this notation to their spec, and it should be accepted by the vendor. If they're not accepting that, then that's a red flag in the card world, in my opinion. One thing let's go to the slides here. And that's where, I'm not going to share too much secret sauce, but you definitely have to keep the blade sharp. You want to start with a tool that's sharp, and you want to make sure your online operators are inspecting it and resharpen as needed. Also, we add certain features that help the cutting process for a smoother, buttery cut. I don't want to go too much detail on that. And then it's important to have online and post-production checks, which should be done to make sure any faulty product doesn't get out the door to the customer. If it does end up at the customer, then their QA department has to do paperwork, which is time and money they don't have. So, in my opinion, Jeremy, that myth is just not true. It's debunked.
I agree.
All right, this is true that Oliver purchased Clean Cut Technologies a few months ago. I always thought the thicker pouch film was always better, Jeremy. Can you clear that up for me?
It's not always better. In a lot of situations it is. Like we talked about earlier with puncture resistance, nylon is better than polyester. And thicker forms of nylon perform better than, thinner materials. But it's not always the best solution. For example, the thicker material is more prone to flex cracking. So we reviewed earlier about flex cracking and what could cause that. Repeated wrinkling and flexing during a vibration cycle is a likely cause of flex cracking. And we measure that in our industry by Galvo flex testing. I'll show a short video on what Galvo flex testing is. So in that video, that is a Galvo flex tester, and it follows ASTM F392. So what's happening in that test is that there's an 8-inch by 11-inch flat sheet of whatever film you're testing, and it's flexed in the machine direction and then also later on in the cross direction to measure how many pinholes could occur after flexing, in this case 2,700 times. So once it's cycled 2,700 times, it's removed from the sample fixture and placed on a white sheet of paper where dye solution is applied to the center section of the sample. So at that point, it's the sample is removed, and whatever remains, what dye remains on the white sheet of paper, we can consider were pinholes in the film. So on this graph shown on this slide, the left-hand the y-axis is the number of pinholes per 2,700 cycles, and then the x-axis is the type of material. So with 48 gauge polyester, we saw anywhere from 40 to 50 pinholes, and then when we doubled the size, the thickness in the polyester, we saw anywhere from 75 to 85 pinholes. So you can see from this graph that the thicker material actually caused more pinholes in the Gelbel flex testing. If you move to the right side of the graph, you can see that nylon overall performs much better, but 100 gauge nylon did show 3.5 to 4 pinholes, but a 60 gauge nylon showed 0. So again, the thicker material, while there's only a few, it still did show more pinholes. So we can conclude from this data that thicker material, when flex cracking is an issue, could cause more pinholes. So Kevin, do you think that this one is busted?
I definitely think so. Thank you very much, Jeremy.
Great. So with HDPE cards, I have pictured these as flat cards with many different features on them, but with a flat card, I picture this in a pouch, and I picture that there could be risk to the seal. Now, in your experience, do the cards penetrate or push through the seals?
If a card is properly designed and fitted, it should not push through the seal. You always should have multiple points of the card touch the seal to disperse the energy, in my opinion. When the card and product shift, a flat edge is hitting the seals and not an abrupt point. I think that's key as well. An example would be in the case of a 15-degree chevron pouch. I'd not necessarily try to mimic the tip of the chevron shape with the card. A card and product will always shift left and right in the pouch, and that tip, coupled with a heavy device, that could cause you some problems if you're not careful. I'd round off the chevron shape altogether and skip the tip portion. This would allow the card to shift and still hit multiple areas of the pouch. If it hits multiple areas of pouch, you don't want it like an arrow, and it could cause seal creep. If it's heavy and it's an arrow, it goes right toward that pouch. As you said earlier, a correctly fitted pouch is key. You don't want it too tight. You don't want it too loose, kind of the Goldilocks effect. Too tight, the seal's already stressed. It's prone for failure. And then too loose, the card and the weighted device are gaining momentum toward those seals, and issues could arise. A great fit is key on all components of the packaging system. I couldn't stress this enough. You can design the perfect card, but if you misfit the pouch, shelf, or shipper, you could easily fail all your testing and cost yourself time and money you don't have. And usually the blame goes to the card, though not justified. That's why I preach about fitting all the components, even though our core product is the card itself. The last thing you can do is rails. Rails can be added to help prevent seal issues as well when needed. The rails keep the card very stiff. If not stiff, a card could flex in the pouch or slump in the card, creating that excess room you don't want and allowing for more movement. And uncontrolled movement in a unicorn is typically just not a good thing.
Those are some really good points, Kevin. Thank you. And I think that myth is also busted. So, Kevin, recently at trade shows, and specifically at HealthPack, there's a lot of discussion around large packaging and handling, but more specifically disposal. So is large packaging disposal, is that usually very difficult?
100% that is not difficult. It's not true. We can make up to 4-foot, 5-foot, 6-foot cards, make sure it stays rigid when unloading the device. But after that card has done its job, it can easily be broken down. Also, you can build in features, as you see it in the slide photos. The first slide shows how to roll the card up, and this particular design, our design team has built in a locking mechanism to keep it rolled up. From there, you would just open the hand and drop it into the bucket or recycle bin from that point. And then you got picture 2. We've added cut creases or scores, which are like half cuts in the card. It takes a lot of the machine. As long as it's properly set up, it should be a 50% cut, and now allows the card to fold into a third and drop into the recycle bin as well. And as most people know, the virgin HDPE that we use is 100% recyclable. So I think I couldn't be more adamant that this myth has been busted.
How about card design? Now, when I picture cards, I think about, I've seen a lot that have different types of hold downs, different design features that are associated. Are the cards difficult to design?
No, I think it's great. They're simple. I mean, as long as you have a vendor that has the right experience and resources. I don't think that's true at all. I think cards can be very easy. I think you should just find a company that has a complete catalog, historically tested tabs, retention elements, and designs. They have the know-wherewithal to do what you need to do or get you the right design for the product. At Oliver, we have the ability to cut up to 72 inches right now. By the end of the year, I'd say we were going to have a machine in here to cut up to 82. And, just if I could say anything, a recommendation is to always design from the inside out when possible. You want to start from scratch to optimize the size of the packaging. In my opinion, this will make the product more competitive downstream. And anytime you can take up less closet room, that's a plus.
Great, Kevin. I think that one's busted as well.
Jeremy, rigid trays, are they the only way to optimize aseptic presentation?
No, they're not. Rigid trays are a great solution for aseptic presentation. It's a very common way to give one of the best protection and also the best handling. If you have a pouch, though, we can use cards in there. So trays are not the only optimized configuration. So, with the pouch in a tray, so if you look at a pouch without a card, handling could be a little bit difficult. The components could be spread all over the place. There may not be organization. So when you add a card, you really could increase that usability. We have a short video next that shows the aseptic transfer from a pouch into a simulated sterile field. So from the video, you could see that the devices were organized on the card. They're still protected, probably more protection, and the design promotes a smooth transfer into the sterile field. It lands nicely on that flat portion of the card and presents itself nicely to the surgeon that's waiting for it. So in our industry, recently the new edition of 11607 Part 1 was released earlier this year. There is a new focus, an enhanced focus on usability evaluations and performing those during your development projects. So if you have a pouch solution, even if it's with existing pouches but also with new pouches, adding a card could really increase the likelihood of passing the first time. So I'm going to go ahead and say that myth is busted.
No, that's good stuff. Thanks, Jeremy. All right, and our last 4 slides here for the show is a case study. We had a particular client, a large MDM, failed packaging late in the process. So if you go to the next slide, we're going to go over that. All right, the failure was due to pinholes in the film, also showed signs of abrasion and flex cracking. They had 2 devices. You had the core device or the main device and a sheath in the pouch. And both were pretty long, over 36 inches plus devices. They used a very thin film, 48 gauge PET or PET. And what is the deadline? We had to ask more questions now that we know the scenario. What is your deadline? And they said 45 days. So that included design, paperwork, POs, production of the parts. They had 45 days, which is not much time at all. Do you want to incorporate your accessory piece in the design? So we always ask if there's accessory pieces or other packaging that hasn't been presented to us. You really want to get the best bang for your buck. If you're going to buy a card or do a card, you might as well put those kitting items on there. In this case, they said, yes, we have a guide wire that would help us eliminate a pouch, shelf, and shipper. So not only do you save money, it's more green. That's always a plus. And if we go to the third slide, we had to ask more questions, and the main question is, how is it sterilized? Is it gamma, E-beam, EO, which cards, our packaging is good for all 3, but in this case, it was ETO. And could there be possibly changes down the line? So important question to ask, because if you just got to pass this testing, if you're in the heat of the moment, you might have to over-engineer a little bit to make sure you pass. But of course, over-engineering packaging affects the end user a little bit, that they don't have such a good time with it. So you got to find that balance between making the end user happy but passing that testing. And then you want to think about the third person, the manufacturing people putting this together. You really want to come up with designs that are easy to load and unload. We asked if there's coatings or materials that can be scraped or easily damaged. A lot of shafts or soft material can have indentations as well. In this case, the answer was yes. We thought maybe put it in the tube to make sure you protect those coatings. If the device gets to the end user and it's not functional, that doesn't do any good for anybody. And then the biggest question is, how would an additional failure affect the project? And the answer was they'll miss their launch date. If you miss a launch date, it's a big deal. So that tells me I need to over-engineer just slightly, make sure that we pass or have the highest chance of passing the rigorous testing coming up. So now that we thought about the whole thing, we got all the questions. I'm sure there's a few more we had to ask. We go to the next slide, and that shows the results. We optimized the card design for them. We had a fold-over flap, as you see on the left side there, where we added the guide wire to it, but also the cover covers the handle and makes sure the film and the device itself don't rub and cause particulates. So it works in twofold there. On top of that, we did the pop and lock rails, which is a rail we came up with last year that patented. We semi-assemble those rails. We ship them flat. You can store it flat, but when the manufacturing person goes to put it together, they apply a little pressure, snap it into place. You'll actually hear a clicking noise, and then you have a nice stiff card from that point. The shelf and shipper were sized appropriately. We went with a nylon Tyvek pouch. I believe all these attributes gave it its best chance to pass. We did our portion of it, and they did pass their design verification test on the first go, and the product went to commercialization from that point. So a job well done by the whole team over here. And that concludes our portion of the slides. I think we are going back to Chris right now.
All right, thank you, Kevin. Now, before we begin with today's Q&A session, please direct your attention to our webinar survey available on the right-hand side of the presentation window. If you close the survey, you can reopen the widget by clicking on the icon along the bottom of your screen. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're going to now move on to the question and answer portion of our event. As a reminder, to participate in our Q&A session, just type your question into the text box located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen. And please note that we'll try to get to as many questions as we can in the time that we have left. If we're unable to get to your question today, someone will get back to you after the program is over. So with that, let's get started with some questions for you gentlemen. I've got a bunch coming in here. Our first one says, can HDPE cards be used to coil tube-like products more efficiently?
I'll field that one. Can you repeat the question one more time, Chris, for me?
Sure, Kevin. It says, can HDPE cards be used to coil tube-like products more efficiently?
Well, I'm not completely clear on the question, but I'll describe one of the capabilities that we have. We have the ability to take tubing, weld it in any shape to a card, as long as the tubing isn't kinking, right? That wouldn't do anybody good. But yes, we have the ability to, a lot of these devices have to have 3, 4, 5 inches straight on the distal tip. That falls perfectly into our capabilities where we can form any shape with the tubing welded to the card. On top of that, people have heavy handles. We have straps. We have different retention devices that can easily grasp that. And so it makes for a great low-profile package, which makes for a great optimal oversized package in general.
My apologies there. I meant to mute myself. I had a cough there. Okay, we have another
That's quite
question
all right.
for you here. Any creative ideas to prevent folding of excess pouch material at both ends within the shelf carton for higher profile products?
I'd have to think about that a little bit. Depends on the device. As you know, every device is a little bit different, but the higher the profile of the device, the tougher the challenge comes because you got to go wider on the pouch. But you don't want to go so wide that it makes you uncompetitive or non-competitive with the other products out there. But yeah, we usually try and fill up the pouch as much as possible with cards. We have flaps. that are at the end of the card to protect the device, but also keep that pouch from creasing or doing a compound fold. So yeah, I hope that answered the question, but that's one that I could go, ask a couple more questions of that person and give them more details offline.
All right, thank you, Kevin. Can you explain what FFS is?
Yeah, I'll take that. So FFS stands for Form, Fill, Seal. So what that is, if you can picture this, is a large piece of packaging equipment. And so again, back to my slide on that, it's a higher capital investment. So what the machine will do is take roll stock, two types of roll stock. So you have a bottom web roll stock and a top web. So the bottom web goes through a forming station. So you're forming a three-dimensional pocket, like a pouch right there. So while you're forming that, the next step, you can have operators in your clean room load those pouches, or you can have robotic automated equipment load product into those pockets. Then next, so that's the forming section, and then the filling section. Next is the seal section. So it goes through a sealing area where the top web comes down and seals onto the bottom web, or the pouches that have been created with the device in it. And then through there goes to a cutting station. And you can also have printing direct on that. You can have labels applied. So really what it's doing, it's a higher capital investment, but it could save you material costs because you're actually doing most of the processes in-house rather than supplying, externally sourcing them from another vendor. And we can help with that. We don't ourselves. We do at Oliver provide the roll stock. So if you do have an FFS inquiry, we can help, and we can tie you in with equipment suppliers as well, and we can have a conversation about that. So please contact us for more information.
All right, thank you, Jeremy. We have another question here that asks, when is the right time to use a double sterile barrier?
I could take this one too, Kevin. So double sterile barrier is a very common question, when to use it. And a lot of the times people think that it's a requirement in some areas. In my experience, I haven't seen it as a requirement anywhere. So you can have a single sterile barrier with something like a containment pouch inside. So when you think about when to use a double sterile barrier, if you think about the end user and what they perceive with that, they'll perceive that they have two chances, and this is feedback that a lot of us in the industry have received, is that they like it because they have two chances to aseptically transfer. So if they open the outer barrier and the inner falls into a non-sterile area, they have another chance to have the device remain sterile and then aseptically present that into the sterile field. Now, there's a lot of things to consider with that. There are risks. Do you even want to present that option to your customers because of, handling, overhandling? One big thing about using a double sterile barrier that's coming up in the medical device regulation in Europe is that we are now going to be required to label every sterile barrier as such. So if you have two sterile barriers, you label them that way, and you have to do validation testing for both. Now, again, this isn't required, so you may want to consider a containment pouch for maybe a cost reduction internally, but also just know that it's not a requirement. One last thing to consider, it's very important. We talked about this with folding pouches. Very common that the inner sterile barrier will be folded or creased to fit inside of the outer sterile barrier. This is, we recommend to avoid doing that because of Tyvek sheet separation and a lot of other issues that could happen. So not a requirement, but there are certain circumstances you just want to get some feedback from your users and maybe from your marketing group to understand why you'd be doing that.
All right,
yeah, and I'd like to add.
Go ahead.
I'd like to add to that, Chris, that I can't tell you when to use it or when not to use it, but I will say it makes packaging a little bit more difficult because there's more movement in that shelf carn when you have a double pouch, especially with heavy, long instruments. So just keep that in mind.
All right, thank you, gentlemen. We have another question here that asks, how are the devices attached to the card?
As I mentioned earlier, this is Kevin. As I mentioned earlier, our design team has a catalog of retention elements. We use things that have worked in the past. Anything that did not work, we get rid of. So we have keyholes, we have pop-ups, we have straps that are easy to assemble and unassemble, And then we utilize that virgin tubing quite often for catheter shafts. So there's an array of different ideas and thoughts and intelligent designs that we use to hold that device onto that card. And then again, I can't stress enough to properly fit everything else.
All right, thank you, Kevin. Another question here asks, do you have experience with heavier implants and HDPE cards?
This is Kevin. Weight doesn't really, people always think, in my experience, that weight is an issue for HDPE cards. That's not the issue. It's just finding certain features on the device to grasp and hold properly. If you can find that, and usually we do, weight doesn't come into play. You just want to properly control it or put it in the right place on the card into the packaging system. So no, weight doesn't scare us off. Bring those types of projects to us and you'll have a high success of passing testing.
All right, thank you, Kevin. Another question here asks, how do you best match the size of the filled and sealed pouch to its shelf box to reduce folding and creasing of the pouch?
Jeremy, is that me?
Yeah, you can start. I can add to it if you don't mind starting.
Yeah, I mean, I don't know a ton about rigid trays. Jeremy definitely knows a lot more about that, or form, fill, and seal. But you want to match the height, or what that would actually be the width dimension, the height of the device, the highest profile there. And you just want to limit movement as much as possible. So you would match the edges and then the shipper, and you can do a single wall 275C, or you can do a double wall if you want built like a tank. But that shipper will take a brunt of the damage, and the shelf card should do the rest of the work. So the tray and the Tyvek lid should do fine by itself. So some people, if they are having cracking, because I've heard certain materials after sterilization are prone to crack, we'll come up with like a little insert that holds it or keeps it away from the edges of the box by like a ½ inch or an inch. So we'd have to see the specific application, but that's my thought on it.
All right, thank you, gentlemen. We'll move on to another question here that says, can you describe more about the pros and cons of cardboard versus HDPE?
I would start with saying I don't know a ton about SBS material, so I don't want to comment too much. I know that clients have come to me that have used historically SBS cards, and they're being flagged for over too much particulate, and that really falls into the quality world. That isn't my forte. But yeah, a lot of clients have to switch over to HDPE. That HDPE is a non-particulate driven product, and then SBS, it's paperboard. So, and usually you don't take paperboard and make it in a clean room or an ISO 8 or 7. So it's one of those pay now or pay later situations, in my opinion. If paper is a lot cheaper, it can be manufactured a lot faster, but at the end of the day, years later, when you hit FDA approval and onto the marketplace, it usually pays off to go with a card that's made out of HDPE.
All right, thank you, Kevin. Another question here asks, how do insert cards impact the manual packing process?
Well, it's a little bit different than a tray where you have to fold up certain tabs before putting the device on there, but we always, again, we think about passing testing, we think of the end user, but we care about manufacturers. So we came up with the ELF. We always encourage people to have loading fixtures. We came up with the ELF, which is easy loading fixture. You can always inquire with Oliver about that, or we can guide you to make your own. But we want everybody to fixture up. We care about hands. We care about people. Our design crew tries to make it assembly as simple as possible, much like the pop and lock. But again, if it's a conversation we should have, we should fixture up and make sure these are as easy to assemble as possible.
All right, thank you, Kevin. Another question here asks, is the HDPE backing card extruded at Oliver?
Oh, this is rapid fire. No, it is not extruded. We get the virgin materials from outside extruder that we've used for years and years, and we bring it in here, and then we convert the tubing and card to size.
All right, thank you, Kevin. We have another question here that asks, what's the risk of items dislodging from the insert card?
If it's poorly, it all goes back to design and experience. It really does. There's probably thousands of people in the past over the last 20 years have made cards. That might just be a die cut, a labeling company that has the machines to do it, and why not take the money and try it? And then there's companies that focus on this, but it has to be the core product. They have to had a lot of successes in the past, and they've probably had some failures that they learned from. So I just encourage people to make the calls, have 20 questions to ask, and hopefully the boxes are checked off all the way through.
All right, thank you. We'll move on to another question here for you. Would you recommend sealing under vacuum as a potential solution to restrict movement opposed to a card? Or I guess as opposed to a card?
Would you?
Kevin, I can start that one, and then you can... You want me to start with that? Just because I don't have as much experience with cards as Kevin does, but I do have experience with vacuum sealing, and kind of my perception of these cards is, it's a good solution. Vacuum sealing does help, especially if you want to go to a film-to-film pouch and you want to ship at a high altitude, because usually if you have air in there, it could expand. So what the card's doing, it is helping right size it, like Kevin went over. But to me, even with vacuum sealing, if you vacuum seal a card in your pouch, you could have a nice organization. So when you aseptically transfer, you're still going to get that nice transfer and that nice presentation. So you could use them in combination. I don't think vacuum sealing would replace the benefits of the card, though.
Yeah, and I'll add to that some of my customers do a light pull, and that's fine. But if you do a heavy pull, you just got to let our design team know ahead of time so we can make the card robust and rigid so it can withstand that and still protect the device.
All right, thank you, Kevin, and thank you, Jeremy. Our next question here asks, what strategy would you use to protect a pouch from a sharp medical device contained inside?
I think that is a key. Sorry, go ahead, Jeremy.
No, you can add to it too. I mean, there's a lot of thought that needs to be put into that. It depends on where the sharp is, where the sharp edge. If it's a blade or some kind of syringe tip, you would want to consider a sheath or some kind of covering on that as much as you can. If that can't be avoided and you know where that's going to be, using a more puncture-resistant material like nylon we were talking about. Vacuum sealing could help a little bit. Protective packaging could also come into play there, where that sharp edge is going to be and you can't avoid it. You can put more protective packaging around there too. So, we do give that assistance here at Oliver. We can sit with your packaging design team and walk through a risk assessment of these aspects. So we'd be happy to do that in more detail offline.
All right, thank you, Jeremy. We've got another question here that says, is there a rule of thumb regarding an increase in height or length of product and the change in width or length of the 2D pouch?
There's nothing that we can really talk about. We need to take that offline and go into more detail. And again, we can help with that design here. We do have experience with that. We use internal calculators that help you get a prototype that could be around the right size. Now, it's a little bit tricky because if the real life aspects of devices, you could measure height, but it's where and how you're loading that device into a pouch could come into play on how long you want it to be or how wide you want it to be. So again, if we have the ability to help you with that, we'd be happy to.
All right, thank you. We've got one more question here. What are the standard thicknesses of HDPE backing cards?
Well, pre-purchase, Clean Cut had 23, 28, 35, and some 14. Now that we are part of Oliver, we've added to the arsenal. I think there is a 25 and there's a 30 gauge as well. I'm not 100% on that 30 gauge, but something around that. So we have plenty of different gauges to pick from. We use the material thickness in the thought process of our designs. We use the memory of the card for the tab. So if one tab wants to fold down, we use that to hold the device in there. So the thickness of the material really gets thought out about in the formula for creating these cards.
All right, looks like we have time for just 2 more questions here. I'm going to sneak them in really quickly, and then we'll have to wrap. But our first question here, do you have applications where HDPE cards are used in conjunction with a tray?
I'll field that one, Jeremy. Yes, we call that the vault, where we have a tray that might be off the shelf or they create. It's perfect for when someone has tons of SKUs or lots of families of instruments where we find commonality, or our design team finds commonalities between all the instruments, and we find 1, 2, or 3 cards to house basically hundreds and hundreds of devices. It's perfect for ortho and different fields. We've had great success on that, so that's something I strongly encourage. Instead of doing tons of different other packaging for individual instruments, think about that universal card.
All right, thank you, Kevin. And our last question for you here, gentlemen. Have you ever been able to down gauge the pouch film by adding a card? For example, to go from nylon to 48 PET or 48 PET after the card is introduced as a part of the system?
I think that if you do down gauge, a card would help in that. Years ago, when I first started, it was all 48 PET, and we had a design completely different than we do today now that we're using a lot of nylon. You just got to be, first of all, the MDM or the person asking for the packaging needs to convey that what material they're switching to so we can design appropriately. And when it goes down to like a 48, you have to start putting flaps over stopcocks and any hard plastic. So a lot of thought goes into that portion of it. You just want to make sure that if you're designing packaging, and especially cards, that we actually get a physical device and see the different materials. We got to know if it's tacky or if it's smooth, if it's metal or plastic. That all comes into play when trying to make the perfect package.
All right, well, thank you, gentlemen. That is all the time that we have for questions for today. We'd like to thank Jeremy Elwell and Kevin Fisher, Packaging Digest. Appreciates your time and expertise on today's topic. And for our audience, if we did not get to your question today, someone will get back to you after the program is over. And we'd like to thank everyone in the audience. We appreciate your attention and participation. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. And please feel free to invite your colleagues and peers who may not have been available to listen to today's event. This webinar is copyright 2019 by Informa. The presentation materials are owned by or copyright by Packaging Digest and Oliver Healthcare Packaging, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests, once again, we'd like to thank you for joining us, and we hope you have a great day.